Three requirements of X-ray production: a source of electrons, a means of rapidly accelerating or energizing those electrons, and a means of rapidly decelerating or de-energizing those electrons. If any of these requirements are missing, X-rays won't be produced. In radiography, all three steps of X-ray production take place inside of the X-ray tube. Electrons are produced in the X-ray tube at the cathode filament. The specific process is called thermionic emission, which is the release of electrons in response to heat. A current running through the filament causes it to become extremely hot, so hot that electrons are actually dissociated from the metal and form an electron cloud around the filament. This is kind of like the filament in an incandescent light bulb. A current running through the light filament creates heat, which creates light. In an X-ray tube, the filament gets so hot it creates free electrons. So a cloud of electrons doesn't do us much good. So what happens next? That's where the unicorns come in. Not really. The second step of X-ray production is accelerating these electrons, which gives them extremely high kinetic energy. This is accomplished by applying an electrical voltage called the kilovoltage peak, or kVp. The kVp creates a strong negative charge in the filament that forces the electrons across the X-ray tube to the positively charged anode. And this makes sense since opposites attract. The electrons are repelled by the negatively charged cathode and attracted to the positively charged anode. The last step in X-ray production is decelerating the electrons. These highly energetic electrons slam into the anode of the X-ray tube. In the process of decelerating, they release their energy as heat and, more importantly, as X-rays. The number of X-rays and the energy of X-rays are actually controlled by the operator using the MA, kVp, and the exposure time. Increasing the MA, or the tube current, increases the number of electrons produced in the X-ray tube. Increasing the number of electrons increases the number of photons. This is the idea of intensity or quantity. The effect of changing the kVp is slightly different. Increasing the kVp, that's the tube potential, increases the energy of electrons in the X-ray tube. The higher voltage makes them move faster. Increased electron energy results in increased X-ray energy, and this is the idea of beam quality. Increased electron energy also increases the total number of X-rays produced, and that's mainly because high-energy electrons are more likely to be converted into X-rays. So increasing kVp increases both the number and energy of X-rays created. Increasing the exposure time also increases the total number of X-ray photons created. The exposure time is just the amount of time that electrons are flowing through the tube and X-rays are being created. It is exactly like unicorns. The longer they eat Skittles, the more rainbows they make. In summary, X-rays are not produced by magic or unicorns. X-ray production requires three things: a source of electrons, that's thermionic emission; a means of accelerating the electrons, that's the kVp, and a means of decelerating the electrons, that happens at the anode. MA and exposure time influence the total number of X-rays created. kVp influences both the number and the energy of X-rays created.